Hey guys, this is lesson 3 for unit 1 of Algebra 2. We are going to take a whole bunch of review stuff from Algebra 1 and we're going to smoosh it into a single lesson. We're going to be talking about solving equations, as you saw from the title card and what's on the screen right now. And we've got a lot to cover, so let's jump right into it. The first type of problem we're going to be looking at is converting English into math. Okay, so we're going to take a couple examples, try to jog the memories and all of those things. So we're going to write an algebraic expression, excuse me, to represent each verbal expression. Okay, so we're going to start with 5 less than 6 times the cube of a number. Most of this is pretty straightforward. The part that I want to highlight and remind you of is this word than. Okay, so when we see than, what I teach is for people to think put at end. Put it at the end. Okay, so this is important. So there's going to be a little part of the expression, and we're going to take whatever was before the than and we're going to stick it after it. Right, that's supposed to be an arrow. I don't know. We'll call that good. Right, so that when we see the word than, we need to think put it at the end. So if it's more than, it's going to be plus whatever. If it's less than, it's going to be minus whatever. Right, and so in this case, we've got 5 less than 6 times the cube of a number. So we're going to take 6 times the cube of a number and we're going to write that. So 6 times, well, what would that be? That would be multiplication, right? So 6 times the cube of a number. What would be the cube of a number? Well, it would be n or x cubed. So n cubed less than 5. So minus 5. Easy peasy, lemon squeezy, no big deal, right? Okay, so let's look at the next one. The product of 2 more than a number and 5. So the product of these two things is and 5 and 15. 5 with a 1 in front of it, right? So the product of 2 more than a number, okay? So 2 more than a number, so that's going to be n plus 2. See how we put the 2 at the end? It doesn't actually matter with plus, but it's best to get that and practice that always, because then we get that locked in our brain, because it does matter with the minus, right? So the product, what does product mean? Well, product means times, right? So the product of this and 15. So we got to do the product of this whole thing. The product of 2 more than a number. And so when we have product or quotient there, we're almost always looking for this word and as well, right? Because that separates the product of this and that. So the product of 2 more than a number, so 2 more than a number is on one side of the multiplication and 15 is on the other side, right? So 2 more than a number and 15. Remember that if a number is next to parentheses, that's multiplication. So that's pretty easy peasy, right? Let's look at the other way around here. So let's pull up our second type. So this time we've got some equations, not expressions. We know they're equations because, oops, helps if I'm in the right layer here. We have an equals. Equals makes it an equation instead of an expression, right? So we're supposed to write a verbal sentence to represent each one of these. So let's start with this one. Now, on these ones, unlike the other one, there's really only one right answer, right? The other way where we're taking words and turning it into expressions or equations, there's really only one way to write that answer properly. This one, there are several different possibilities, right? We could do 5 times a number. We could do the product of 5 and a number. Any of those things would work. So let's do, how about 5 times? Let's do it. So my recommendation is, I mean, you can get as cutesy as you want to get as long as it's right? You can have the coolest sounding way, but why not just go for the simple, straightforward answer? And in this case, like you've been saying it for a long time, we could say 5. Let's write it out all the way in words. 5 times, when we have a variable, we just say a number, right? Or you could say times the variable x. You could say that. We're gonna go in a little more generic direction. 5 times a number. You can do 5 times a number x. right? You can do that as well. We're just going to put 5 times a number. We're not going to worry too much about what that letter is in this particular example. Is equals. If something is something else, they are equal, right? It's bad grammar, but good math, right? 5 times, speaking of bad grammar, 5 times a number is 27. 27. No big deal. All right, let's do another one. So a number minus 3, or 3 less than a number, or the difference of a number and 3, right? There's several different ways we could write this. I'm just going to say a number minus 3 is 15. Right? We could write this a whole bunch of different ways, but that is definitely one possible correct answer. That's easy peasy. You probably did that early on in an Algebra 1 class, right? Hey, so we talked about in our last lesson, properties of real numbers. There are a handful of properties of equality that we're going to review. We definitely have seen these before. We talked about them in our geometry classes, in our Algebra 1 classes, and all of those things. So let's go over these properties real quick because we use these to solve equations. What is the reflexive property? Remember, that's the easy one. In geometry, I like to call it the no-duh property. It's kind of obvious. We do use it in geometry. You might remember that. And the reflexive property simply says A, where A is a real number, all these are real numbers, equals A. Wow. Rocket science, right? This one equals that. No big deal. It means they are the same. So they can be substituted. More on that momentarily, right? So the next property of equality is the symmetric property. Okay, so the symmetric property says that if, I'm getting the right layer here, kind of working my way up this lesson. Okay, so if A equals B, then in fact, B equals A. So we can flip them around, right? Which is useful, right? We typically want to write our X on the left and our number on the right, right? So if we end up with the number equals X, then we can take and flip those around. Really, really great, easy peasy. That's what the symmetric property lets us do. Okay, so let's hit the next one. The next one is the transitive property. I like the transitive property because it sounds cool, right? So the transitive property is kind of, you're going to see in the example, it's kind of like the substitution property, sort of. But it's, and that statement will make more sense when you see the example. Examples, there's 2 of them. So the transitive property says if A equals B and B equals C, then A equals C. So if A equals B, and then if B equals C, we can take and put A equal to C, right? We'll show the difference between the transitive and the substitution property in the examples and kind of how they work. So the substitution property says that if A equals B, then B can be used anywhere there is an A, right? We use the substitution property a lot in geometry, right? If this all equals that, then we can take this little chunk right here and we can shove it up in this other place, right? We use that a bunch in geometry. We use it a bunch in Algebra 1 as well. We just don't always highlight, oh, substitution property. We do often say, we're substituting this for that, right? And we're going to use that a lot more. This property, we're going to use it plenty in this, whatever this is, this course as well, right? Substitution property. All right, let's do some examples. Okay, so we've got two different thingamabobs. We've got two different problems, some examples, and we're going to name the property in each one. Now, you may have already guessed by what I've already alluded to earlier in this lesson that one of these is going to be the transitive property and the other one is going to be substitution. So let's take a look and see which one's which and how it works. So this first one says if 3a minus 4 equals b and b equals a plus 17, then this beginning equals the ending. 3a minus 4 equals a plus 17. So this one is, whoa, phone notification. Forgot to silence it. Oh, well, be all right. We'll all live. Hey, so this would be the transitive property. Transitive property, right? Now, this next one, let's take a look at it. If 2g equals h minus 62 and h equals 24, then 2g minus 24 equals 62. So what did we do? We took 24 and we substituted that for h. You see, it ended up in the same place as the h. So this is the substitution property. Substitution property, right? Easy peasy. Let's keep on trucking. Now that we have the tools to solve equations, let's remember how to solve some equations. Let's do a few practice problems there. Okay. Oops. I don't know what that is. It's okay. All right, we got a couple of one-step equations. Now, these one-step equations that kicked them up to an Algebra 2 notch and stuck fractions and decimals in there. Fractions and decimals at this Algebra 2, I shouldn't, I'm being sarcastic really, have to say this. However, I am going to say it, and that is fractions and decimals, partial numbers, are just numbers. Nothing changes. You have a calculator if you forget how to do it by hand. Sometimes it's faster to do it one way or the other way, but fractions are just numbers. All of the same rules apply, and it is important that I stress that because I know that even at this point in your math career, you may be still like, oh my gosh, fractions. They're just numbers, folks. This fraction is multiplied times a y. How do we get rid of it? What's the opposite of multiplication? We divide it. It's easy peasy. Let's do this one first. So we have x minus 4.98 equals 63.7. So how is that 4.98 attached to the x? Well, it's subtracted. So how do we get rid of it? You guessed it, add it. So add 4.98. Add 4.98. Now, this is muy importante. It's very important, right? Your work, you are in Algebra 2. Your work needs to look like my work. It needs to look pretty like that work, right? It needs to look good. It needs to look lined up. It needs to not look like a giant mess. You are not in middle school. I am talking with serious voice because I want you to hear me well. This is how your work needs to look. My handwriting isn't even perfect, but it's still good enough and it's lined up good enough. Now, I will not count off if you don't do this. I still highly, 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 highly recommend using a different color on the intermediate steps. This still is a good strategy. This works for general ed and special ed and everybody in between. It is a useful strategy for dyslexia. It's a useful strategy for learning disabled. It's a useful strategy for just the general populace. It is a good strategy. It helps keep you organized. It makes you slow down enough to change colors. It's a good idea. Try it. You'll thank me later, and it won't take you much more time, and you'll save time in the future by getting more problems right the first time, right? So these two cancel, right? Leaving us with just an x on the left side, which is great. That's our goal. 63.7 plus 4.98. You could, of course, do that by hand. You could also do that on the calculator, which I'm going to illustrate doing, right? So we're going to put in 63.7 plus 4.98 equals 71.67. We're going to either circle or box our answer, and we're going to call it done. My goodness. Had to sneeze. All right. Let's look at this other one-step equation. We have a fraction, I already said, multiplied onto a variable. So how do we get rid of multiplication? We divide. Now, the next question is how do you divide fractions? Go back in your brain and remember, how do you divide fractions? You divide fractions by multiplying times the reciprocal. So that's how we're going to get rid of this. We're going to multiply both sides times negative reciprocal. So 5/7. If we do it on one side, we've got to do it on the other side. Negative 5/7. These cancel, leaving us with just a y. I said one step, I meant it, right? Equals 12 times negative 5/7. Now you could go grab your calculator and do all of that nonsense, but it's going to be a lot faster if you have your times tables memorized through 12 to just be like, oh, look, this 12 and 7 don't reduce. 12 times negative 5 is negative 60, so the answer is negative 67. Moving on with our life, circle our box, our answers. Don't be afraid of fractions. They're just numbers. You can do this. I know you can. I have faith in your abilities. We're just nearly done. We've just got a handful of more equations to solve. One abstract one, which you're going to love. It's going to be great, grand, and glorious. All right, we've got something a little bit more complicated here, but it's really not that scary. We're going to solve this for x, right? So we've got these little numbers times parentheses, both of these here. So your brain should be flashing distributive property. We reminded you of that in the last lesson, and that's exactly what we're going to do in this particular problem. Now, if there was just one of them, like if all of this was gone, then you could either distribute that to or divide it because it's times everything. But because this is still there, we really have to do this one with the distributive property. And it's worth noting, like I just said, that you can always do it with the distributive property. It might save you a step if you notice other ways to do it. And in Algebra 2, you may want to kind of start thinking about ways to do things quicker because you know more stuff. But if you do shortcuts, make sure you do them right? So in this one, we do have to do distributive property on both of these things because we have to, right? We can't get rid of things any other way. So 5 times x is, of course, 5x. 5 times 3 is, of course, 15. And then 2 times 1 is 2. And then 2 times negative x is negative 2x. And then bring down our equals 14. It is worth noting, I don't know if I've said this before or yet in any of these Algebra 2 videos, but it is worth noting that when you are taking these notes, that you make sure whenever I do a step, make sure you are checking in. Even if you have to pause the video for half a second, make sure you are checking in with yourself and make sure you understand, okay, I get why we did that. Because if you're not doing that, then the temptation will be to just sit here and take notes and write down what's on the screen and then never really actually learn anything. Make sure you check in and you understand why we're doing something. If you're one of my students, then make sure if there is something that you're confused and you cannot for the life of you figure out why did he do that in that video, make sure you put a big old star, question mark, highlight, whatever. Make sure and ask about that in class or in our Discord or either way so that you are understanding every piece of the puzzle. So make sure you check in with yourself and know what you're doing. Don't just blindly write down stuff. So we've got a bunch of mess over here, but we do have like terms, right? We've got this guy and this guy. We've also got these two, right, that we can combine. When you combine like terms, when we learned this, we reviewed this. We didn't learn it last time, but we reviewed that when you combine like terms, you're just adding those coefficients. So 5 plus negative 2 is 3x. And then 15 plus 2 is plus 17 equals 14. So we have two things to get rid of. Now, if you've been in my classes before, you definitely know that it is easier on something like this to get rid of the addition subtraction first. You can get rid of the 3 first, but then you got to divide everything by 3, and then we get unruly fractions for no reason at all. And so it's easier if you get rid of the addition subtraction first. So how is this 17 attached to the x? It's added, so we're going to do the inverse to get rid of it. So the inverse of adding is minusing, subtracting. Minus 17 minus 17. That cancels, leaving us on the left side with 3x equals 14 plus negative 17 is negative 3. How is this x attached? How is this 3 attached to the x? Excuse me. It is multiplied, so we get rid of it by dividing. We're going to divide by 3, and we're going to divide by 3 over here. So x equals, what is negative 3 divided by 3? Well, it's negative 1. No problemo. Now, it's worth noting in this Algebra 2 class, if you end up with, like, say something like negative 5x plus 12. And or not 12, not plus, equals 12. And then we're dividing here. We're dividing by negative 5. Divide by negative 5. That's probably a 5. That cancels. At this point in an Algebra 2 class, I am totally fine with, and this has been true for a little while in my math classes, but for those of you who are new to me, if you can leave this as an improper fraction as long as it's reduced. In fact, that's what I recommend doing, because then and keeping it as a fraction, don't change it to a decimal or anything like that, because it just basically spits out the answer, because see, this is the answer, right? So that's worth noting. If you do end up with an improper fraction, as long as it's a reduced improper fraction, that is fine, as long as it's not a word problem. In a word problem, we probably want to get the decimal equivalent. But, you know, there it is. I think we've got one more set of examples. Yes, we do. Okay, so I forgot to add a layer. There we go. So this one, I told you we're going to do an abstract algebra problem. This is it. The formula for the area of a trapezoid is A equals 1/2 h plus B1 plus B2, where h represents the height and B1 and B2 represent the measures of the bases. Solve the formulas for B2. So we're talking about a trapezoid, something like this, quickly, crudely drawn, right? The h is the height, and this is B1 and B2, which doesn't really matter, but that's what we're talking about, to get that back into your brain, what's going on. What we're talking about is we want to take this formula, and they want us to solve this for B2. So I'm going to rewrite the formula down here a little bit bigger, right? So the area equals 1/2 h times B1 plus B2. Now, you ask, why would we want to take and solve this for B2? Well, this is actually a really common thing. That's why the formulas in chemistry or in physics are, I know this is going to, those of you who take those classes are going to be like, what are you talking about? But that's why they're as pretty as they are and isolated as they are, because they're solved for the variable that we're interested in. And you can resolve those using this method. That way you have less algebra at the end. You can kind of front load the algebra. And this is how to get formulas that focus on what you want, which lets you do things in Excel, lets you do things in programming, all kinds of things, all kinds of reasons why we might want to rearrange an equation. So we're going to do that and remind ourselves how to do that. So we're solving for this guy. So what does that mean, solving for this guy? That means we're trying to get this guy by himself, everything else on the other side. Now we've got multiple variables, so they're going to stay in there. We're not going to get a pretty B2 equals 5, right? We're not going to get something like that. We're going to get B2 equals blah, right? So that sounds scary, but let's take a second. It's not going to be as bad as it sounds. So we're trying to get rid of the stuff. So we got to get rid of the stuff on the outside of this parentheses first. Now you could distribute it, right? That might be tempting to do, but if you distribute it, you're going to have to factor it back out again in order to do it. What we need to do is we need to get rid of this stuff first. So how do we get rid of that? We'll even do them one at a time since this is early in Algebra 2. How do we get rid of this 1/2? Well, it's attached to everything else by multiplication, right? It's right next to stuff. So that means multiplication. So how do we get rid of multiplication? We do the inverse, so we divide it. How do we divide fractions? We multiply by the reciprocal. Look how much we're remembering some of the stuff. So what's the reciprocal of 1/2? Well, it's 2, because 2 over 1, right? So times 2 times 2. So the first line after getting rid of the half would be 2a equals h. I forgot to write that. I almost rewrote it because I forgot. H times the quantity b1 plus b2. So we still need to get rid of the stuff outside of this parentheses. We could distribute it back in, but then we'd have to factor it right back out again to get rid of it. So how is this h attached to the whole rest of this sign? It's multiplied, right? So how do we get rid of multiplication? Well, we divide. So we're going to divide both sides by h. You see how even with letters, I said fractions are just numbers. Letters are just numbers. I mean, they are. These all represent numbers, right? And so we're handling them just the same way. The only trick is they stay in there. They don't kind of scoonch and reduce down. They stay in there. They stay kind of ugly, but we're handling the same way. This h is multiplied. How do we get rid of it? We divide it. So it's all the same rules, all those same properties of equality we're using to do what we want to do. This is kind of foundational to high school algebra. Maybe not real algebra, but that's a discussion for like college and stuff. So, there it is. All right, so we've got 2a over h on the left side, and then all we have on the right side is b1 plus b2. Now it's pretty easy, right? This is pretty straightforward. So how are we going to get rid of the b1? Because remember, we're solving for b2. Well, how is it attached to b2? It's added. So what's the opposite of adding? The inverse of adding? Subtracting. So we're going to subtract. You see how it's the same as if it was numbers. Easy peasy. It really isn't that bad. Now, over here, this doesn't combine. Those are not like terms, so we just have to write them down next to each other. So I'm going to kind of move this up because I've run out of space here at the bottom. And we're going to write this as 2a over h minus b1 equals b2. Now, we like to write what we're solving for on the left-hand side. So the very last thing I'm going to do, just to clean it up and make it more typical of what we expect, I'm going to put the b2. We're going to use the symmetric property, right? And put the b2 over here on the left and write this as 2a over h minus b1. So what is this formula that we just derived? Well, this formula right here is the area of a trapezoid. This is the formula for the area of the trapezoid. It is just focused on one of the bases instead of on the area, right? And so that's what that is, and that's an abstract algebra problem, and that is it for this lesson. If you're one of my students, thanks for joining us. Able to fit all that stuff in a vaguely decent amount of time. If you're not one of my students, thanks for joining us as well. Let us know how else we can help you with math, science, or general homeschooling. Have a wonderful day. Bye-bye.